Hello everyone, so the past few days I've been trying to set up my Raspberry Pi to become a packet sniffer. The way I've set it up is I have the Raspberry Pi acting like a man in the middle between two computers that are communicating with each other. And the way I did this was the Ethernet cable from one computer goes into the Ethernet port on the Raspberry Pi, and the Ethernet cable from the other computer plugs into a USB to Ethernet adapter. I got this one here, it was about £3 on eBay. So you have two Ethernet inputs going into the Raspberry Pi. So in my case, I have into the USB adapter, I have my laptop connected to it, and to the other one it goes to my computer over there. So if I turn the Raspberry Pi on, what I have it set up as, I have it run two scripts when the Raspberry Pi starts. The first one is a shell script which sets up a bridge between the two ports. I tried lots of different sort of methods of trying to get this to work, and this is the only one I could seem to get working. I tried using IP tables to forward data from one to the other, but I couldn't seem to get it working. This is the only method that actually worked for me. And yeah, so these two are bridged together using a software bridge, and a shell script is used when the Raspberry Pi starts to start the bridge automatically and get it all set up. Another script I have starting up automatically is one which is a Python script which runs TCP dump over and over and over again, and dumps the files to the Raspberry Pi so you can access them later on. So if you look on the Raspberry Pi at the minute on the display, you can see you can see like a little error there coming up with the bridge, saying the bridge hasn't been assigned an IP address, which is actually what we want. I realise you can do packet sniffing using things like ARP cache poisoning and things like that, where you put a fake entry into an ARP cache to redirect traffic to you. But I think doing it my way is a lot more harder to detect. I think, I'm not entirely sure, but I think it is. I can't think of a way of detecting it unless you sort of take into account the delay in packets and stuff maybe going through the Raspberry Pi, because it will slow them down a little bit. But yeah, this here is the Python script I have running, and yeah, as I said, it starts TCP dump and dumps the files to the Raspberry Pi, and it does that every minute, but I can change that in the script. So yeah, as you saw there, the minute passed and it dumped file number 1 to the Raspberry Pi there. Okay, and it loops, so it's doing it again now for the next minute as it goes through. The script looks like this, and I'm going to put this in the comments. Basically, there's a while loop which is true all the time, so it's constantly running. It runs it does a sub process popen to TCP dump process, and it runs this TCP dump command here. So it outputs it to a file called file name, which is generated using this string up here, which is basic concatenation of the day, the month, the year, the hour and the minute, which is just off the screen there. So you can tell from the file name when the capture was taken. So it runs that command, and it then prints out when it's dumped the file to the Raspberry Pi that it's dumped. The reason I had this in a Python script, I was going to have it so it uploaded as well to Dropbox, as you can see this by this commented code here, but I couldn't get that working because the way the Raspberry Pi is set up is it doesn't have the two interfaces here and here aren't assigned IP addresses. That's one of the things the shell script does. It takes away the IP address on the Raspberry Pi, so you can't even SSH into it. The reason it does this is because when I tried it making a bridge between the two with the IP addresses, it just didn't work. It wouldn't forward any packets through. So just as a test, what I have at the minute is when it focuses, I've got Wireshark running on my laptop here, and I can ping the laptop through this. Just there you go, and it's replying now, sending ICMP echo requests, and you can see on here that they've come up here. So the data is going through the Raspberry Pi. It's going through from the computer all the way through to the Raspberry Pi into this port here. The Python script is dumping everything that's going through here and yep, so it dumps it. It then goes out here to this, and it isn't modified in any way. It probably could be sort of quite an easy thing to do to modify packets. I haven't looked into how you do that, but yeah. So yeah, that's all there really is to this video. If anyone knows how you get the Dropbox, how you would be able to access the internet and upload to something like Dropbox with no IP addresses on them at the minute, I'd like to know. I'd be very interested in how you do it. Okay, one thing I forgot to mention is the shell script I used when the Raspberry Pi starts up to set up the software bridge looks like this, and I placed this along with the Python script in the rc.local file so it starts automatically. But what this does is it gets rid of the IP address on ETH0 and ETH1, which is the Ethernet interface on the Raspberry Pi and the USB to Ethernet interface. So it removes the IP addresses. It then creates a bridge called bridge 0, and it then adds ETH0 and ETH1 to that bridge and then brings the bridge up. And what you can see on the Python script is part of the TCP dump command that it runs. It has this option here which at the minute is set to ETH0, but this can be changed to be set on to capture packets on the bridge, on bridge 0. So that's what I used when I had the Raspberry Pi running, capturing the packets on the thing just now. So what happens when you capture the packets? I took the SD card out the Raspberry Pi, as you can see, and I mounted it on my Ubuntu. It's just a virtual machine I use for certain things, and I CD'd into the Media James and then the SD card there, and I have these 4 files here. That one, that one, that one, and that one. And the way I have this set up at the minute on the script is every 60 seconds, as you can see there, it creates a new file, and this can be changed to, like, I don't know, 3600 if you wanted to do it every hour or whatever, but I had it set for a minute just so it's a better example, not having to wait ages. So yeah, so what they're the files there that it saves, and you can open them in Wireshark, which I just edged, and it shows you the file. And yeah, so there's the file with all the data running through, and you can filter out the ICMP requests that we did with the ping command just by typing in the ICMP in the filter there, and you can see the echo request and replies there. So yeah, that's a little example of how it works. Thank you for watching. If you have any questions, please let me know and I'll try to answer them for you. Goodbye.